So yesterday we are done with the implementation of a circular queue using array, and this is the code for it. We had a discussion on it, and we have seen the entire implementation, but we did not see the execution and with some example. So let us see that how the circular queue overcome the drawback of a linear queue. What was the drawback of a linear queue? Memory wastage. When you start deleting the elements, the free slots which are created out of deletion, those free slots cannot be reused in a linear queue, and that leads to a memory wastage. And that problem of memory wastage can be easily overcome in circular queue. So let's execute this code. Okay, what executed? And this is application session 15. This is an implementation of a circular queue. So what we'll be doing, we'll be straightforward inserting the elements, and we know that the size of the queue which we have defined is pi. So let me go for the pi insertions. I insert one more element 40. I insert one more element 50. And now let me see the content of a queue, both options. So this is the queue content, but into this display function, we do not have the information regarding the front and the rear, which is important for us. So let me do that. Let me stop this execution. And in the print function, or in the display function, uh, when we are displaying the content of the queue, so where we can display. We can call it as queue info, queue info. And into this, we can front equals to percentage D, then a type space, then where equals to percentage D. And here I would be displaying queue of front, comma, queue of rear. So that's the queue information, and then comes the queue content. Okay, that's enough. I think so. Let me save this code, and the compile code is already running. I think I need to restart my Visual Studio Code. Fine. So I compile this code. Okay, compiled. So this is now overwritten. And now when we insert the data elements, so I insert 10, then I insert 20, then I insert 30, then I insert 40, then I insert 50. Let me display. Okay, so see carefully the queue content and the queue info. In queue info, what we have front is 0, rear is 4, and this is the queue content. And if we try to insert now any element, say I want to insert 60, so 60 cannot be inserted but it is not showing me the queue full message. Some part of the code is still to be done. This is not the copy of the linear queue program. Fortunately, where I did not do all those stuff. So in this insert, there is a return value. If the return value is not true, then I should say that it is full. So if this is not returning me a true value, then I can print printf queue is full. Or in fact, there must be a check now. Here I am returning 0. Okay, I'm not going to recompile the code again, but we are understanding that 60 is not inserted, and the reason is that the queue is full. Okay. Now the idea is to delete few elements and see that whether those space which has been created out of deletion is getting reused or not. Okay. So here the 60 is not inserted because the queue is full. I go for some deletion. So element deleted from queue. Absolutely not a good programming. I'm not displaying here which element got deleted. Okay, but 10 was at the front of the queue, so it is expected that 10 got deleted. So I display the queue and see here the queue contain 20, 30, 40, 50 and queue info, the value of front is 1 and the value of rear is 4. So it means that the index value 0, we have a space or we have a empty slot at an index value 0. In case of linear queue, that slot cannot be reused. Okay, because the queue is still full as per linear queue. But this is a circular queue, so our queue is not full. And if I go for some insertion, say I say choice 1 and I want to insert 60. Now, what is important that the insertion is done from the rear end. Okay, so the frontmost element is still 20 now. If I see the frontmost element, so the frontmost element is 20, it should be 20, 60 should come after 50, okay? Though it will be stored at the index value 0. So let's see. And let's display. Okay. So now this is interesting. If you see the queue content is 20, 30, 40, 50, 60. And 20 the frontmost element, its index value is 1, and that's why the value of front is 1, and most importantly the last element, this 60, is stored as at the index position 0, and that's why the value of rear is 0. Okay, and that's the reason that it's a circular queue. So we do not know whether the front is ahead of rear or the rear is ahead of front linearly. That's why we need to make use of that mod max to check the relation between the two. So here in this case also we can see very clearly our queue is full. Our queue is full and the value of front is 1 and the value of rear is 0. Okay. So if I try to insert any element now, for example, I want to insert 70. It is not giving me any message, but the reason is what? The 70 is not inserted and the reason is the queue is full. So if I display, 70 is not there. I have element 20, 30, 40, 50, 60. Okay. So this is your circular queue and this is how a circular queue makes use of the free slots which are created out of a deletion or from a deletion, and it avoids the memory wastage, which is a major drawback of your linear queue. So that drawback is avoided in your circular queue. Okay? Any query into this? Please, is there any query related to circular queue? I have a code execution in front of us. If you have any query, then practically right now we can see. Else we can switch to the next topic. Any query, please put your query into the chat box, or you can unmute your mic and you can talk. Our circular queue program is executing, and if there is any query related to circular queue, or you want to check for some condition, then the program is executing right now. Practically, we can see that, and practically we can discuss on that. So if you have any query, please put up your query into the chat box, or you can unmute your mic and you can ask your query. Yes. If no question, understood? Everyone understood the circular queue now completely? Please reply to the chat box. Okay, okay. These conditions are very important. In circular queue, you need to only remember mod max. Okay, and what is the biggest shortcut? Shortcut when you compare your linear queue with the circular queue implementation? In linear queue, when you insert the element, it is there plus plus. Okay, or if you put it up inside your assignment statement, that is queue of data in square brackets, queue of where. So there you can write plus plus queue of where, the increment operator. So in short, insert of a linear queue plus plus queue of where, insert of your circular queue, queue of where equals to queue of where plus one mod max. Mod max is important. Okay. Then everything else is same. Then about the delete function in linear queue, it is queue of front plus plus, and in circular queue, it is queue of front equals to queue of front plus one mod max. Okay. Queue full condition for linear queue, queue of where double equals max minus one. Queue full condition for the circular queue, queue of front double equals queue of where plus one mod max. Queue of where plus one mod max. Okay. So only with this few differences, you are ready with both the programs. An implementation of linear queue using arrays and implementation of a circular queue using arrays. Okay. Okay. Now let's talk about the third type of queue, that is priority queue. Yeah, what is priority queue, and then what do you mean by double-ended queue? So what I would be doing, that I will make a copy of this. Let me call it as 16, session 16. Okay. And then let me go full screen for you people. So I stop this presentation and I present again. This time I would be presenting only a window. Okay. So now it comes as a full screen to you people. Let me open session 16. Fine. Okay. So yes, now this is priority queue. and. So a linear queue is a simple implementation of a queue, and it is also called as a simple queue in which your indices, front and rear, both moves in a linear fashion. A circular queue is a queue which overcomes the memory wastage problem of a linear queue, and the indices move circularly. So it feels to have a circular structure, and that's why the name is circular queue. And then the third type of queue is a priority queue. Now, can you tell me what can be a meaning of a priority queue? Means what can be a priority queue? Why the name is priority queue? And most often, you should remember that most often the terms which are used as a name for any concept, it's a reflection of that concept. Okay, so from the name itself, we should understand what is the concept all about, or what does it mean, or what should it mean. Okay, so priority queue. So what can be a meaning of a priority queue? Any attempt? Any student can try for it. Priority queue. What can be a priority queue? Come on, it is not that difficult. You can easily, in fact, guess it. Yes. What is a priority queue? Please, you can answer into the chat box, or you can unmute your mic and say, what can be a priority queue according to you? To give priority to some elements. Okay. Okay, fine. Anybody else? Okay, she is absolutely correct. It is about giving or assigning priority, but not to some elements, but to all the elements. Okay. So each and every element of a queue will be having a priority apart from a data. Fine. Then another is saying arrange the elements in a queue according to their priorities. Yes, finally we need to do that. So what is a priority queue? A priority queue is a queue in which each and every data element has got a priority value. And then the data elements are processed in a priority. I repeat, and then the data elements are processed in a priority. It is as good as that you have a priority, you have a queue at a ticket counter at a railway station, for example, and then people are standing in a queue. So whoever comes first will be served first. First come, first serve basis. This is the approach of a linear queue. In linear queue and also in a circular queue, whoever comes first, that person would be served first. Okay. So the element which comes first, that element would be served first. First come, first serve basis, FCFS. First come, first served basis. But in case of priority queue, the element has got the priority values, and they are then processed or they are then served as per their priority values. Okay. Now this is not that much important that which element came first. What is more important, which element has the highest priority. So now the elements would be processed or the elements would be deleted, in short, on the basis of their priorities. So the element which has got the highest priority would automatically come to the front end of a queue and then would automatically get deleted or get processed first. When I say deleted first, I mean to say processed. Okay. So do not take the literal meaning of the delete. Here, basically, deletion means it is getting an opportunity to use the shared resource. I repeat, it is getting an opportunity to use the shared resource. Okay. For example, you are standing into a queue at a ticket counter. So when we say that you are getting deleted or you are removed from a queue, it means that you have been served. You have been given your ticket. Okay. So since you have been given your ticket, so you have to be removed from the queue. You will be deleted from the queue. So basically, when we say the element is getting deleted, so it means that that element is getting an opportunity or a chance to be served. Okay, so here in priority queue, all the elements would be deleted, and when I say deleted, I mean to say they would be served. Okay, so the elements would be served or the elements would be deleted depending upon their priority value. So the element with the highest priority would be deleted or would be served first. So it simply means that the moment the elements are inserted into the queue, they are always inserted from the rear end and they are deleted from the front end. Okay, the concept remains same. Insertion and deletion point remains same. Insertion would be always done from the rear end and deletion would be always done from the front end. What is important that at any point of time, I repeat, at any point of time, the elements are arranged in the queue in the order of their priorities. The elements are arranged within a queue in the order of their priorities. So the element with the highest priority would be at the front of a queue. So the front would be always pointing to the element which is of highest priority. Then the second highest priority element would be second. The third highest priority element would be third, and so on. And then the lowest priority element would be at the rear of the queue. The lowest priority element would be at the rear end of a queue. Okay. So now the question can be that fine, we understand that all the elements in the queue now would be processed or would be deleted in the order of their priorities, and each and every element is going to have a priority value. Apart from its data, the element is going to have a priority value. Okay. But the question can be how to arrange or how to set the data elements in the order of their priorities. And the bigger question is when to set. After every insertion, the order is expected to get changed. Because, for example, we have three elements in our priority queue. And these three elements are already ordered in their priority according to their priorities. They are already ordered. The moment one more element is inserted, this element is inserted with its own priority value, and now this order have to be again changed. So if this element is the highest priority among all these four, then this element would come first. If it is the second highest, then it would come second. If it is the third highest, then it would come at the third position. If it is the least priority element, then it would come at the fourth position. Okay. But the point is what? That after every insertion, the order, the sequence of the elements has to be arranged. Okay. So it means that we are going to order the elements as per the priorities after every insertion. Or after every insertion, we need to again reorder the elements as per their priorities. Okay, so that whenever I want to delete any element, I am quite confident that the highest priority element is at the front of a queue and that element would be deleted first. For example, again a railway ticket counter. There's already a queue. Okay, and now if a person with that smart card, which is issued by a railways, so if that person comes, so that person can directly go at the front of a queue. Okay, or if a person wants to take a first class ticket, even that person can also directly go at the front of a queue. It means that those people who want to have this kind of service, they have a higher priority and they directly comes at the front of a queue and then they get served. In the same line, in a priority queue, every data element is going to have a priority. Now, in infix to postfix conversion, we have seen what do you mean by precedence when we were handling the operators. So every operator has got a precedence. Precedence is nothing but a priority value. And when we implemented it, we implemented it in the form of an integer number. So basically, a priority or a precedence can be an integer value. And you can go with any logic that more is the value, more is the priority, or less is the value, then less is the priority. Okay. It means that a number, a data element with a higher priority number is going to have higher priority, or you can implement in a reverse way. A data element with a lower priority value means 0, 1. So these data elements are going to have higher priority. Okay. So it is up to us how do we want to implement. It is up to us how do we want to implement. But one thing is for sure, that apart from the data, every element is going to have a priority. Okay. Now, if you see for a linear queue and for a circular queue, when we stored the data, we stored the data into this array. Okay. So now, data of 0 is one element. Data of 1 is another element. Data of 2, data, this array name is data. So I am saying from that perspective, data in square bracket 0 is the first element, data in square bracket 1 is the second element, data in square bracket 2 is the third element, then 3 and then 4. Because the max is 5, so we'll go up to 4 only. So these are the elements in a queue, or these are the data elements in a queue. Now, apart from the value which we are going to store into these data elements, that is 10, 20, 30, 40, 50. Apart from these values, every data element is going to have a priority value also. I repeat, in a priority queue, apart from the value or apart from the data, every element is going to have its own priority value. That priority value can be implemented in the form of integer numbers. That also we have seen. Now my question is how to handle this situation. Means for a linear queue and for a circular queue, we have an array like this, int data of max, and into this array our data is stored. All elements got stored. But now for a priority queue, we know that apart from a value, every data element is going to have a priority number. So this is my first value, the priority number of that. Then my second value, then its priority number. Then my third value, then its priority number. Then my fourth value, then its priority number, and so on. So now how to handle this in case of a priority queue? Whether this simple array is capable enough to handle the priority queue? Or can we implement, I mean to say, can we implement the priority queue with this structure, which we have used for the linear queue and circular queue? Is this structure enough to handle the priority queue, or we need to do something? Some extra has to be done. Come on, answer, please. You can answer into the chat box, or you can unmute your mic and you can say the answer. Chalo, fast. We don't have much time. We need to complete this part, then we need to switch to double-ended queue also. Come on, programmers. When we implement a priority queue, so how you are going to handle this situation? Every data element is going to have a data value and priority. Data value and priority, data value and priority, data value and priority. Earlier we had only data value, then data value, then data value, then data value. Only data value. So we implemented it in the form of array. Okay, a simple array. But now with each and every data element, we have a priority associated with it. Then data element, then its priority. Data element, then its priority. Data element, then its priority, and so on. So how to handle this situation? Whether this simple array is enough for us, Can we create a new array for arranging elements according to their priorities? Then another student says that we can go for two arrays, and one student says that we can use 2D array. Absolutely right. The simplest approach can be to make use of a 2D array. The array which we have right now in front of us is a 1D array. This array. This array is a 1D array. Okay. And now we got answer from a few of the students, and they are saying that we can make use of 2D array. So absolutely we can make use of a 2D array. Now what do you mean by 2D array? 2D array is nothing but your matrix. Okay, your matrix of some rows and some columns. Matrix of your some rows and some columns. So for the circular queue and for the linear queue, what we had a 1D array or a simple array in which we had only the data elements. Fine. Now, the idea is that in priority queue, we do not have only the data element. For example, 10 is my data element, then 20 is my data element, then 30 is my data element, 40, and then 50. So we don't have only this data elements or data values. Apart from these data values, we also have the priorities. So, for example, the priority value is 3, then here the priority value is 2, then here the priority value is 3, 1, then priority value 2, then priority value 3, something like that. Okay. Then whenever you have a same priorities, whenever there is a tie, so it is obviously the element which came first. So whichever element came first, that would be served first. Okay. So whenever there are the multiple elements with the same priorities, with the same precedence, then they would be served in the order of FCFS, first come first served basis. So now you do not have a single element or single data value. Apart from the data value, you also have the priority. Okay. So how to handle it? Uh, the simple thing is to handle it with the help of a 2D array. Okay. So we have a 2D array. And into this 2D array, what we can see that this is my column number 0, and this is our column number. This is our column number 1. Okay. And this is my row number 0, and then this is my row number 1, and then this is my row number 2, and this is my row number 3, and then this is my row number 4. Okay. So these are my rows which I can see along this, and these are my columns along this. See my cursor, how my cursor is moving. So in short, what I mean to say, these are my columns, column number 0, column number 1, and then these are our rows. Okay, 0 to 4. Fine. Now, so here we can see that in this setup, now we are capable enough to handle the two things. So in the 0th column, in the 0th column, you have all the data element values, and in the column number 1, you have all the priority values. Okay, so this becomes a 2D array, a two-dimensional arrays. You have rows and columns. Okay, and here the important thing is what, that the column number of columns are fixed. You are going to have only 2 columns, because your first column would be storing all the data element values, and your second column would be storing the priority values. So since you are going to have two things associated with each and every data element, that is the value of that data element and the priority, so we'll be having two columns. And the number of rows depends upon the number of data elements you want to handle. Okay, so now we have defined the array of size max. So if you say max is 5, so there would be 5 rows. If you say the max is 10, then there would be 10 rows. If you say max is 500, then there would be 500 rows. But the number of columns would be fixed. Okay. So in priority queue, if I declare a structure for a priority queue, the structure would be something like this: struct and say PQ for priority queue. And inside this structure, we are going to have our since our values of the data element, that is the first column, is of type integer, and my second column is also of type integer, that is the priority values. So both the elements or both the values of each and every data element are of integer type. That's why I'm taking this array as of integer type. So int, then I say data, and how many rows I want. It will be 2 square bracket for multi-dimensional array declaration. The first square bracket represents the number of rows, and second square bracket represents the number of columns. So how many rows we want? We want max number of rows. And how many columns we want? We want 2 columns. Okay. So it will be int data in square bracket max, and then the second square bracket 2. Okay. And the front and rear would be same. So in front, comma, rear. Then this max can be defined as 5, 10, or 100 as per our choice, as per our requirement. Okay. So this is a structure for a priority queue. And now the data array is a 2D array. We have max number of rows and 2 columns. And then whenever you are going to insert a data, you are going to handle it accordingly. Whenever you are going to delete a data, you will be handling it accordingly. So what I mean to say is that when you insert a data, you do not need only the data element value. You need two things: the data element value and its priority. And after insertion, you need to order them. Now the ordering can be done with the help of sorting. So then here into priority queue, you need to have some sort of sorting algorithm. So after every insertion, you will be calling up that sorting algorithm, and the sorting would be done on the basis of priorities, not the data values. I repeat, sorting would be done on the basis of these priorities. Okay. So the element with the highest priority would come at the front, and the element with the lowest priority would come at the rear end. Okay. So this is what we need to do after every insertion. So after every insertion, you can call your sorting algorithm or the sorting function. That sorting function would sort this queue in the increasing order of the in the decreasing order of their priorities. So the element with the highest priority comes at the front, and the element with the lowest priority goes at the rear. So then whenever you delete an element, whenever you process an element, so you will be deleting from the front end, and the front end element is the highest priority element. Okay. So that is our priority queue. I hope the theory part or the conceptual part of the priority queue is clear to you. And then comes our double-ended queue. Now, what is this double-ended queue? In double-ended queue, not only both the ends of a queue are open. For all kind of queue, both the ends are open. One end is called the rear end, from where the insertion is done. Another end is called the front end, from where the deletion is done. But in double-ended queue, both the ends are open for both the things. I mean to say, from the rear end, you can insert the data, you can delete the data. From the front end also, you can insert the data and then you can delete the data. Okay. And then in double-ended queue, you have again two types of queue. One is called input restricted queue. Input restricted queue. and second one is called output restricted queue. Now, from the name itself, we can understand it, that what does it mean. In input restricted queue, it's a double-ended queue. So both the ends are open for both the things. Now, in an input restricted queue, the input is restricted. What is restricted? Input is restricted. It simply means that you cannot input a data from both the ends. And generally, from which end we input the data? We input the data into the queue from the rear end. So, in input restricted queue, you can insert the data only from the rear end, but you cannot insert the data from the front end. But you can delete the data from both the ends. So the input is restricted, but output is not restricted. So you can delete the data from the rear end also, or you can delete the data from the front end also in input restricted queue. Likewise, in output restricted queue, your output is restricted, means your deletion is restricted. So you can delete the data element only from the front end. But when you talk about inserting a data element, so the insertion can be done from the rear end, and the insertion can also be done from your front end. Okay, so the insertion can be done from both the ends in output restricted queue, but the deletion can only be done from the front end. So the rear end is closed for deletion in case of output restricted queue, and in case of input restricted queue, input is restricted, so the data cannot be inserted from the front end. It only be inserted from the rear end, but the data can be deleted from both the ends. Okay, so you can delete the data from the rear end and you can delete the data from the front end in case of input restricted queue. Okay, so your double-ended queue is a queue in which the data can be inserted or deleted from both the ends. So you can insert and delete the data from the rear end, or you can insert and delete the data from the front end. And then in double-ended queue, we have two types. What is called input restricted queue, another one is called output restricted queue. In input restricted queue, input is restricted. It means that output can be done from both the ends. Output means deletion. So deletion can be done from both the ends, and insertion, input can only be done from the one end. And that one end is obviously going to be your rear end. Okay, so you can insert the data only from rear end, not from the front end, but you can delete the data from both the ends. In output restricted queue, output is restricted, so you can insert the data from both the ends, either from rear end or from the front end, but you can delete the data only from the front end. You cannot delete the data from the rear end in your output restricted queue. Okay, so that is about our double-ended queue and priority queue. And I hope that the theory part or the concept of priority queues and double-ended queues are clear to you. If you have any query into this, please put in your question into the chat box, or you can unmute your mic and then we can have discussion on that. Okay, so I stop the recording, but we can continue discussion. Siddiqui Aitesham. Recording will be saved in Siddiqui Aitesham's Google Drive.